Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, all participants of the ICEDES International Seminar. Good afternoon to ICEDES Seminar Committee. I will present my article with the title Heat Transfer Analyze Single Slope Solar Steel or S4 with Vacuum Type. My name is Irfan Santosa. And then my second authors are Eko Prasetya Budiana, Agus Wibowo, and Galuh Renggani Wilis. This is my introduction. We know that as the population grows, the need for water increases for drinking, bathing, cooking, and so on. It is predicted that in 2030, the water demand will reach 6,900 billion meter cubic, and 14% of people will use desalination technology such as membrane desalination and conventional desalination. Therefore, desalination is solution to cover this need. Several studies we conducted to increase the productivity of the distillate water, such as the development. Uh, this is geometry, development of geometry like single slope, double slope, tubular slope, triangle slope desalination, including the type of vacuum conducted by Omara and Irfan in this research, where the research conducted by Omara and Irfan only discuss the performance of the tool and does not discuss the heat transfer. And then the purpose of this study is to calculate the value of heat transfer uh, based of temperature from the research of Omara and Irfan. Can you see the parameter single slope solar steel? This is Omara, and then this is Irfan. Uh, when viewed from the geometry, Omara desalination tool has an area 0 and 0.5 square meter, and Irfan 0.6 square meter. The same material is made glass with an angle of inclination of the cover glass 30 degrees. Basin body cover from iron set and aluminum foil, condensate pipe for vacuum with copper and with the same copper. Fan blower for vacuum is the same. Use a fan blower. And then volume of seawater in the basin 10.15 kilogram, and then 12 kilogram. This is a calculate heat transfer in the single slope solar steel from the measurement temperature data and then analyze its heat transfer. This one calculate from radiant heat transfer coefficient, heat transfer rate, seawater to the glass, and then heat transfer rate, uh, cover glass to ambient air, and so on. So this is a result. Can you see the seawater temperature graph? Both research data show that the temperature has increased from uh, 11 to 15 o'clock. Can you see the graphic? This is a blue graphic, blue chart Omara and orange chart Irfan. Can you see this temperature graph? Both research. And then this is a glass temperature, and then this is ambient temperature of both research, and then this solar intensity. This is a calculate value of heat transfer. Can you see this is a graphic radiant heat transfer rate from the seawater to the glass, and then this is a value. This is a graphic the radiant heat transfer rate from cover glass to the ambient air, and then convection heat transfer rate from seawater to the glass, and then graphic convection heat transfer rate from the cover glass to ambient air. This is an average value of radiant and convective heat transfer. And you see this is a radiant heat transfer rate from seawater to the glass. Omara, can you see? That's the value, not too same, yeah, not too same is significant. And then the radiant heat transfer rate from cover glass to ambient air. This is a convection. IC convection heat transfer rate from the seawater to the glass. This is a value. And then KR, this is a radiant heat transfer from glass to the ambient air. And then a KC convection heat transfer rate from cover glass to ambient air. And GT is overall heat transfer, overall value heat transfer. And then this is a heat evaporate value, and then this is a solar intensity value. This is productivity distillate from Omara, just bigger than Irfan. Omara have a value 278.75 milliliter for 9 hours research, and Irfan just 78.12 milliliter. So discussion also from seawater temperature data, RTV ambient temperature TA and the cover glass temperature, both are not too significant difference than the average value of the radiation heat transfer rate from seawater to the glass and the average value of the convection heat transfer rate. And you see this is a graphic total heat transfer coefficient, and then this graphic heat for the operation process, and then productivity distillate water. Conclusion of this study show that the vacuum desalination made by Omara and Irfan, the dimension of the tool are almost the same, indicating the value of each temperature seawater temperature, glass cover temperature, and ambient temperature. The difference is not too significant, but the average value of productivity distilled water produced from the two tools saw a substantial difference during 9 hours. And then Omara bigger than Irfan. Productivity distillate. Okay, that's all from my presentation. Thank you and apologize profusely. If have any question, you can email or contact me via number. Thank you. Assalamualaikum warahmatullahi wabarakatuh.